Hello everyone, my name is Miroslav Šedivý and my question is, should we return to Python 2? Because I have seen that although people are already migrating to Python 3, there are still plenty of Python 2 relics in their code. So why would people keep these relics? Why do they want to hope that maybe there will be Python 2 again and then they don't have to rewrite their code again back to Python 2? So should we return to Python 2? The question? No. The answer is no. Because it's already over 1 year that Python 2 has reached the end of its life, and now everything should work already in Python 3 in the latest version. That is much, much better. I work for Triport. This means that I'm using Python to make the sun shine, the wind blow, and the gas flow. And if you would like to work with me in the beautiful city of Vienna in Austria, then just catch me after the talk. So, I suppose that you have already migrated your project to Python 3 entirely. This means that your code works in Python 3. But which version of Python 3 should we support? We are now in fall 2021. And as you can see, it is the time of Python 3.9. There is 3.8, 3.7 and 3.6 that are still bug supported, and 3.10 that will be released in the upcoming weeks. Which means that if you have an application that is working only for you, then just stick with the latest version, Python 3.9. But if you work on a library that should be used by other applications or other libraries, then you shouldn't stick to single version, because give your users the possibility to migrate progressively from version to version. And which means that for a library, nowadays you should support 3.6 to 3.9, or at least 3.7 to 3.9, and at 3.10 when it is out, and then at the end of year remove support for 3.6 and so on, and roll it also in the future. Forget about 2.7 and all Python versions prior to 3.6, they are dead. This means that supporting more versions or multiple versions gives you a little bit more work, but on the other hand, your users will be happy because they have more time to migrate from one of your versions to the next ones. So let's suppose your code runs Python 3. It means your prints are functions, you don't use iter keys, iter values, iter items, and your xrange has been converted to range. Maybe you still have some relics from the migration, so 6, or some code snippets that test the version of your code. And maybe some import errors that import alternatively different versions or different names of third-party libraries. Second, make sure that your code works. If it is on GitHub, just create a nice simple function or simple structure with CI/CD of GitLab or GitHub, and add all the files. So just to make sure that everything works correctly on the server. Then, if your code should support several versions of Python, use Tox. That's a great tool to run several tests or on several different versions of Python very easily, and you're done. Then create a simple CI/CD file where you define the versions of Python you want to run it on, and install with pip, and then just run Tox. And you will see that if everything works, that's fine, because then you have done the step and you can proceed further. Then imagine which versions of Python you want to support, and which versions or which features of Python you want to support or offer. Because let's say that we are now at least Python 3.6, it means that you can already use type annotations, f-strings, and underscores in Numeric Literals. And if you are further in the list, you can add even more functions. If you have a library that should support also older versions of Python, like from 3.6, then of course there is some stuff from newer versions of Python that you should at the at the moment, just ignore them, but hope that in the future, when you drop support for Python 3.6, you can actually already count with sort order of dicts that is guaranteed from Python 3.7. Look at this nice overview from Jürgen Gmach, and let's see what versions of Python support the features that you want to use. Then there are some lines of code that are obsolete now. So for example, if you see like coding UTF-8, you can just remove it because UTF-8 is default in the source code of Python 3. Then if you inherit from object, just remove this object because your class implicitly per default inherits from dummy, or not dummy, from object. Also the super function has its default. All your literals, Unicode literals, are now Unicode literals, so you don't have to put a U beforehand. And there are plenty of such things that you could change manually, but it's also possible to do that automatically. There is a great tool by Otonisotel called PyUpgrade, so just install it and tell, I want to upgrade my code base to 3.6, and it will do all the updates that you have seen on the top of this page and even further ones. The second point, make sure that it looks good. So apply black, blue, yep, whatever you want, and make Flake 8 and or Pylint happy. So you fix the code and it looks good, and the diffs afterwards will be much smaller and more relevant, and there won't be any Flake or Pylint messages. So your code has some good base and is on the level of Python 3.6, 3.7, or whatever version you want as your base version. Then there are some more things. For example, string formatting. The first one, the first format with percents has been obsoleted a long time ago. You can still use it, but it's much better, much nicer to use the F strings from the third line. And format for strings that you have pre-formatted beforehand. There is an exception in log messages because they still support only the percent format, and the reason is that this line will get executed and the string will be formatted only in the case if the current log level is at least info. So you save maybe expensive formatting of strings if you don't need them. Unfortunately, this doesn't support any further syntax than the percent signs. Then, as I told, if you have UTF-8 code link of your source code, stick to the default. There can be exceptions. For example, here in with Latin 1, I had some function with some strange characters, and I couldn't just translate them to UTF-8 and leave them that way. Actually, I have to simulate the behavior of decoding the first characters from Latin 1 or the second characters from UTF-8 to get the same characters. So you will have to play a little bit, but as much as possible, stick to UTF-8 coding that is default in Python 3. Also with characters that are beyond Ascii, so for example my last name, Šedivý, I can type it like that, and I can show you how to type it on your keyboard. But if you don't want to have characters beyond Ascii in your source code, you can use the second possibility, so type directly the Unicode points that are a little bit difficult to read because you don't know what U0160 means. Another possibility is to use directly the names of the characters with \N and curly brackets, where you can put exactly the name of the character inside it, and that's easier to read or to understand exactly what character is there. Numbers, there are some relics that will work in Python 3, both in Python 2 and Python 3, but people who have never seen Python 2 before, like younger developers, they will ask, why is it like this? So for example, in Python 2, if you wanted to do math floor, math sale, or round, and you wanted to get an integer out of that, you had to put int before that. But in Python 3, math floor, math sale, and round, they return already an integer. The reason is that before integers, they didn't have so huge range, and floats had larger range. But nowadays integers are infinite, and that means that you can convert every float. You can approximate it or round it to an integer. Beforehand it was not possible. That means that now there is no reason actually that round should return a float that looks like an integer, but it's a float. Now round returns an integer, and that's right. So if you find in your code somewhere results of math floor, math sale, or round converted to integer, just remove that int. As I told, this maximal integer in Python 2 was number with 18 digits, but in Python 3 integers are not limited, and the floats, they are limited to 1 to the 10 to the power of 308. Another exception is, another thing that has changed is counting, for example, averages, arithmetical means. In this case, for example, I want to calculate the average of 3344. If I take the sum of these four numbers and divide it by the length of this array, of this list by 4, I will get the number 3. That's mathematically wrong, because the sum is an integer, the length is an integer, and integer divided by integer in Python 2 returned an integer. There were hacks, different hacks. So for example, you converted the sum, or you converted the len to float, or you multiplied everything by a float, for example, 1.0. If you see something in your Python 2 code, okay, that was a hack. In Python 3, you don't need that, just remove that. So if you want to have a code that works both in Python 2 and Python 3, in Python 2 you can import division from future, and then it will behave the same way as in Python 3, so dividing two integers will return a float. So that is actually how it should work in both versions of Python. Why is all this hassle with integers and floats? Because God made the integers and all else is the work of man. Use integers everywhere you can. They are great, they are cool, they are fast, and they describe exactly the value that you need. Floats, they are only approximative. So for example, in floats, if you take this big number, the first one that ends with a 3, that number doesn't exist, because at this range, the exactitude or the precision of float is already more than 1 unit. This means that there is a number ending with a 2, and the next possible float is a number ending with a 4, and there is nothing in between. It means that you don't want to use floats to describe numbers with such a precision. And this is not a huge number, for example. This is number of nanoseconds in 105 days. Also, if you count with floats and you add them and subtract them and add and subtract, then you will lose precision. So for example, adding 0.1, 0.1, 0.1 3 times in a row gives you a number 0.3, 0.0004. Actually, that because there is no number as 0.3 in the floating point system of Python. So this is only an approximation. This is like if you have 1 liter of water and you add another liter of water and you subtract 1 liter of water and so on. And every time you do that, then the number will just oscillate and it won't be exactly, it will never be 1 liter. It is always approximately 1 liter. But if you have a bottle of water and you add another bottle of water and you subtract bottle of water and add a bottle of water, it will be always, there will be always 1 bottle of water, because you cannot just divide a bottle of water in 2 or any fraction. Also, if you want to add a lot of floats, for example, here we add the 0.3 1 million times, then of course at the end we will get a number that is only approximately 300,000. If you do that with the decimals, then the result will be exact. That's fine. Also, if you do that with fractions, If you can do it with fractions, because 0.3, okay, that's 3/10, or 0.3 that can be written exactly. That's not a number like p or 1/7. But you see the results will also need a little bit more time. So for example, while with standard float we need 50 milliseconds, then for decimals it's 7 times more, and with fractions it's much more. So remember imagine what purpose you want to work with. If you work with some physical results of physical values, then it's fine to use floats, but as soon as you touch finances, then stick to decimals. Never use floats for finances. Your tax office won't like that. Another reason to keep with integers is actually to use them to stuff that they are designed for. So for example, number of minutes in an hour. There are not 60.0 minutes in an hour. There are exactly 60 minutes in an hour. And with Python 3, you can use 60 as an integer to divide minutes by the number of 60 and to receive a floating point number for the number of hours. Also for averages, or that we have seen already before, the A and B are 2 elements and they are not 2.0 elements. So use 2 if you want to divide or calculate the average. Also for if you want to have the integer division, you can use matfloor or int, or you can use the integer division that is there are 2 slashes. Round x, yes, that's what I said, that in Python 3 round x returns an integer, so that's fine. And that's the only reason where I see actually the usage of round. But however, round offers another possibility when you add a second argument that gives you the number of decimal places you want to round to. But in this case, it returns a float. And actually that will be some approximate float rounded to 2 decimal places. And I find that quite wrong, because actually for many numbers that with 2 decimal places, as we humans understand them, there is no exact floating point representation in Python. That means that why would you want to round some number to 2 decimal places? Maybe because you want to print it nicely. That's perfectly fine, because humans don't want to see floats with 10 decimal places. But in that case, use only the conversion to string, so this formatting. And only here take the floating point number that is in the memory with any precision, and then print it with 2 decimal places, like here. Or with recent Python, you can even use this equal sign within the format that will automatically print the name of the variable and its value. Percentages, that is also something that we convert within our code, although we need percentages only for the presentation. If I want to represent 1/7 in percentages, I can divide 1 by 7 and then multiply by 100 and represent this number as percentages. But when I'm printing it, I can also use the % format that will take happily the floating point number that is not multiplied by 100. So for example, 1/7, that's 0.1428 and so on. And then you can tell it to format it as a % with 1 decimal place, and it will convert everything, multiply by 100 internally, and print it correctly. And I find this beautiful, because your ratio is ratio and not some percentage number that you actually never use in the calculation. If you ever use the percentage number in calculations, you actually have to divide it somewhere by 100, and that's not necessary in this case. Numeric literals is also something that has changed in the recent versions of Python. So for example, if you want to multiply the number of seconds to get the number of nanoseconds, you can do this, but this is wrong, because 10e9 is a floating point number, and you have nice number of seconds in Python in integer, and you multiply it by floating point number, and you already get a floating point number, and that's ugly. So one possibility is to write the number of seconds number of nanoseconds in 1 second correctly, but nobody can read that. The second possibility is this. That's fine, that's nice, because now I can see actually that's 1 billion. And the third possibility, I think the nicest one, is to use an integer, and 10 to the power of 9 is an integer, comparing to 10e9. These were numbers, and there are some other things that have changed in Python 3, and that's pathlib path, and that's beautiful because that's a library in the standard library that will give you the possibility to work with paths as objects. So for example, this code in Python 2 that goes through a directory, looks for CSV files, opens them, reads them, and processes them, can be written as this, and that's beautiful. So you can actually rewrite your code. This is something that you have to do manually, but anytime you have some variable that is usually a string in Python 2 that represents a path, then convert it to pathlib path at some moment, just to show the reader of your code that, hey, I am working actually with paths and not with strings. There is even evolution in Python 2. So for example, removing a file that is not sure to exist. In Python 3.8 you can actually unlink it with missing OK false. Otherwise you have to check whether it exists and unlink it. This also offers you cool features in PyTest. So for example, in PyTest, if you want to have a temporary file, if you do it like this, then it creates some temporary file with some strange name that will be deleted afterwards, or won't be deleted, but you won't find it easily. Use PyTest's temp path standard fixtures that will create a beautiful directory structure in your temp with your name, then the number of PyTest run, the name of the function, and the name you give this file. And it will keep the last 3 runs and delete them afterwards, so you can always check the results of your recent tests. Datetime is also something that has changed. In Python 2, if you wanted to get the Unix timestamp of a datetime, you had to import like another library, standard libraries module, a calendar, and do it this way. That was ugly. But now in Python 3, you just ask for the timestamp and you will get it. Also, we have daytime times on UTC. So for UTC, we have it in the standard library, the information about the time zone. And in recent Pythons, you have also the zone info library or module that takes care of time zones and replaces PYTZ or other modules entirely. And that's great. Also for time.time, you could do this if you want to calculate the elapsed time in an expensive operation. But if during the expensive operation your system clock will be set back or forwards because of its precision, then your result may be even negative. So that's why use a perf counter that will calculate or give you the number of seconds elapsed since some time in the past, but that will be always monotonically increasing and won't jump back. Or use process time if you use the CPU time. This and much more, find it in the 2nd edition of Fluent Python by Luciano Ramayu, a great book that will come hopefully out in the upcoming weeks or months. And as a technical reviewer, I have seen plenty of beautiful Python stuff in it. So, there are Python 2 relics in your code. Should you actually get rid of them? Here's the plan. When someone uses a feature you don't understand, simply shoot them. This is easier than learning something new, and before too long, the only living coders will be writing in an easily understood tiny subset of Python 096. So, thank you very much, and goodbye.